Hello, this is Mr. Ferris again. I thought I would give you another video recording of the lesson. It's just a one-page set of notes. It's the second half of section 6C, and you should have downloaded that off of the Canvas page. So we have maybe a little bit of review to do. You might remember that we discovered that a lot of data, for whatever reason, in real life tends to pile up in a way that looks something like this. A lot of the numbers are kind of in the middle toward the average, and not as many are high or low. And so since a lot of data sets pile up like that, they are kind of messy. You know, they're not a nice, smooth transition from left to right. But we can imagine that maybe if we took a beautiful, perfect mathematical equation like this, it generally more or less roughly kind of sort of fits the data. And the nice thing about the math part is this beautiful curve. We can do all kinds of very precise calculating with the mathematical curve, which is a decent approximation of what's going on in the data. So it's not going to be a perfect estimation for how many, what percent are above something or less than something. At least it gives us a decent estimate, and we're satisfied with that. And you might remember too that the way this is set up, if you take kind of a standard normal curve where 0 is in the middle, if you mark off 1 standard deviation, 2 standard deviations, 3 standard deviations in one direction, and 3 standard deviations in the other direction, you are pretty much at the end of the useful part of that mathematical curve. So we say that a standard normal distribution goes from 3 standard deviations on one end to -3 standard deviations on the other side. And we didn't really mention, I guess, what these numbers were. These numbers here, and if you wrote just the main ones, you'd have 7 numbers altogether. 0 in the middle, and then +1, 2, and 3 standard deviations, and -1, 2, and 3 standard deviations. Positive means it's above average, above 0, and negative means it's below average. And those numbers are actually called z-scores. Z-scores are simply the number of standard deviations above or possibly below the mean. Now again, on kind of the standard normal curve, we just use 0 in the middle and 1, 2, 3, and -1, -2, -3. Obviously, not every data is going to fall exactly on one of these, so the ones that are in between are what we're going to deal with today. So one of the things that you're going to realize or have to figure out is, well, how would you ever figure out how many standard deviations you were? Like if you're, I don't know, 68 inches tall and the average is 60 inches, how many standard deviations above average are you? Well, for that, we're going to need a little bit of a calculation. So let's do this. Let me just draw a bigger version of what I just did there. This is a normal model. Or you know what? I think what I'm going to do is I'm going to actually draw example 1 up there just because it's got a lot more room. So let's just talk about the IQ test, the famous IQ numbers that we've probably heard all our lives. So the standard IQ test supposedly is a normally distributed set of data. The mean is 100, and the standard deviation is 16. So if we I usually like to start at the end. The end, so to speak, is like 3 standard deviations. That'd be 2, that'd be 1. And then on the other end, you got -3, and then kind of subdivide that in thirds. That's roughly how I would mark it. And if the standard deviation is 16, then if you go up 16, you'd hit the first standard deviation, another 16 would be 132, and then the third standard deviation would take you to 148. And then if you go down 16, and down 16, 68, and down 16 again, 52, those would be the numbers that would mark off the 6 increments of 6 sets of 16, 6 standard deviations, 3 on one side, 3 on the other, of the mean of 100. And so, it's not too hard to figure out what your z-score would be for 100. 100 is the mean. And so how many standard deviations would you be away from the mean? Well, you'd be 0. So the z-score for 100 would just be 0. That's how many standard deviations away you are. If you have an IQ of 116, that's right on 1 standard deviations above average. So your z-score would be 1. If you land there, you'd be a z-score of 2. If you landed there, you'd be a z-score of 3. And similarly on the other side. And those are not the hard ones. The hard ones are, what if you landed, like they're saying, what if you landed at 125, for instance? Well, 125 is up in there somewhere. How many standard deviations above average is 125? It looks like it's about 1.5. It's somewhere between 1 and 2 standard deviations, but how far exactly? Well, that question is really asking you, how many 16s are you away from 100? How many standard deviations are you away from 100? Well, we know it's at least 1, and it's not quite 2, but there's a mathematical way to figure that out. First of all, you want to figure out the difference. How far away are you from 100 to start with? Well, 125 minus 100 is 25, but we want to know how many 16s are there in that difference of 125. So it turns out that the z-score formula involves 3 numbers. You need the value where you are, you need the mean, and you need the standard deviation. And if you have those 3 numbers, you can calculate the z-score very easily with just some basic arithmetic. So the z-score for 125 is going to turn out to be 25 over 16, which if you calculate that on a calculator, you get 1.5625. So we were right. It was about 1.5. Actually, it's closer to maybe 1.6 standard deviations above average. That would be the z-score for a person that has an IQ of 125. Similarly, if we did one for 85, that was another part to this. They wanted to know what's the z-score for 85. Well, we would do the same thing. We would take that score of 85. We'd find out how far away it is from the mean, 100, and we would divide by the standard deviation. Notice I'm always subtracting the value minus the mean. That's always the way we want to do that, because when you take the value minus the mean on the left side, that turns out to be a negative number. So you'll get negative 15 over 16, which is negative 0.9375. Again, it's almost 1 standard deviation below average, but not quite. So the formula for a z-score, I'll just stick it up here. The formula for a z-score, we always want to take the value, the data value, minus the mean of all the data, and then we divide by the standard deviation. That's the 3-number formula for finding a z-score. A z-score is, again, the number of standard deviations you are either above or below the mean. So that's a fairly easy arithmetic computation, not too bad. Another idea that kind of goes along with this is the idea of percentile. And it's very possible you've gone to the doctor and they've weighed you and measured how tall you are, and they'll tell you, oh, you're in the 80th percentile or 90th percentile, whatever that might mean. Well, maybe you picked up on that. Percentile is simply the percent of data less than or equal to a value. The percent below, less than or equal to some value. So if you go to the doctor and they weigh you and they say you're in the 90th percentile, what that means is 90% of all people your age and your gender weigh less than you do. If you're the 95th percentile in height, that means 95% of people like you are shorter than you are. So percentile is always percent below. So that's the second half of this lesson, is to calculate the percentage below, which, you know, if it was dots, we could just count how many dots are below and divide by the total. So if it were actual dots, we might do this differently. But if we're going to generalize for some big population that maybe has thousands or millions of people in it, we're not going to want to count that. We're going to want to use the math behind this. And so it turns out there's a formula sheet. That's the second half of your handout. It looks like this. And it's a table, and that's what you're going to be using to calculate the percentiles if you know what the z-score is. And again, percentile, just, you know, as a reminder, it's a nice thing to kind of think about. Percentile, let's say you ended up here on the graph. The percentile is always the percent below. So percentile will be the area below wherever it is that you're looking for. So here's an X that's clearly above average, so the percentile would be maybe, I don't know, 70% or 75% or something like that. And this table would be the table that would give you that number. So let me just pick that 75% number. You might notice that 75%, the 75th percentile, corresponds to a z-score of 0.7. So when you are 0.7 standard deviations above average, then you're higher than 75 or maybe 76% of all other people. This is the table that you will use to get those. There are ways to do it on a graphing calculator, but we're going to just stick with the table because it's fairly simple. So some examples real quick. What percentile is a man who has a cholesterol of 190? Well, the first thing we've got to figure out is the z-score, because this table, remember, to find the percentile, you have to find the z-score first. So we've got to calculate the z-score, which we just learned a formula. The formula is the value minus the mean over the standard deviation. So the value is the age of the man, or I'm sorry, the cholesterol of the man. So that value is 190. The mean up here was 178, and the standard deviation was 41. That is how we're going to calculate the z-score. So if you have a four-function calculator even and do that, you'll find out that you're not very far above average. You're only about 0.29. And remember, that's a z-score. So now we come over to our table and we're looking for a z-score of 0.29. Z-score of 0.29. We got to be careful because you'll notice that the numbers are all right next to each other. So here's the magic answer I believe we're looking for. Now, you notice we don't actually have 0.29. We have a z-score of 0.3. So the closest we're going to be able to get is to look up a z-score of 0.30. So that looks like about 62 percentile. Usually percentiles in real life are given as whole numbers. So we might say that's the 62nd percentile. So for 0.30, 0.30 is going to be, I'm just going to write this as 0.30 just so we know we kind of round it a little bit. 0.30 has a, what did we say, 62 percentile? 62 percentile based on the table. So we looked up the closest thing we could find to a z-score of 0.29, and we got a 62nd percentile for our answer. Sorry about that. I went off the screen there a little bit. So once we calculated the z-score of 0.29, we rounded off to 0.30 so we could look it up on our table, and then the table told us it's about 62nd percentile. So 62% of men have cholesterols less than 190 in this age range. All right, now a little different going backwards. We want to know what cholesterol level on the scale of cholesterol would correspond to the 90th percentile. Well, 90th percentile means 90% are below something. Well, for 90% to be below, that's going to have to be way over here to the right somewhere on the z-score range. So it's going to be positive, maybe 2 or something, 1 point something. So to look that up, we're going to have to use the table exactly backwards. So now we're looking for the closest thing to 90th percentile, and then we see which z-score is associated with it. So the closest thing to 90th percentile would be this one right here. And so now we're going to use the table backwards to actually get the z-score first. So we now know that the 90th percentile is about a 1.3 z-score. So we're still going to use the z-score formula, which is value minus mean over standard deviation, but we're going to start with knowing that the z-score is 1.3. So we had to look that up. We had to look up the 90th percentile in the table and get the z-score of 1.3. Then we can solve this equation. We don't know what the value is, but we know the mean is still 178 and the standard deviation is still 41. So now we've set up a little algebra problem. Hopefully you remember enough from your algebra days that you could do kind of the magical steps there. You'd multiply both sides by 41 and add 178, and I'll do the math for you. It turns out to be about 231.3. So a man who's in the 90th percentile would have a cholesterol somewhere around 231. Boy, I'm sorry, I'm not looking at my screen. So you totally missed that, didn't you? So the z-score formula is what we used. But what we had to do first was look up what 90th percentile means. So 90th percentile in the table corresponds to a z-score of 1.3. So I used the z-score and substituted 1.3. Then the value is something we don't know, so I used x. We still know the mean is 178, and we still know the standard deviation is 41. So this is the little equation that I started with and set up. And using the calculator, I got 231.3. So I'm going to try to make sure I scoot this up so you can see this time. All right, last two sample problems. Now we have a height problem where the mean is given to be 65 and the standard deviation is 2.5. This is for American women, ages 18 to 24. They want to know the percentile for a lady that is 68 inches. So to find percentile, we first have to find the z-score. So by now, hopefully you've got this formula kind of in your mind. You take the 68-inch value, you subtract the mean, and you divide by the standard deviation. So 68 minus 65 is 3. 3 divided by 2.5 is 1.2. So the z-score is 1.2. Now we have to look up in the table what a z-score of 1.2 gives us. So we scan the page. You'll notice that the right half is positive z-scores, the left half is negative z-scores. So we're looking up 1.2. Here it is. The z-score of 1.2 is kind of toward the top right corner. And a z-score of 1.2 corresponds to a percentile of about 88. If we round that off, we call that 88. So once we look that up, that would be the 88th percentile, which means that a woman who's 68 inches tall is taller than 88% of women her age. Last problem. In order to serve in the Army, this is an interesting little fact, women have to be between 58 and 80 inches tall. So I wonder how many women would not qualify based on height. So if we think about our normal model, it says the mean is 65 inches, and one standard deviation is 2.5. So if we go out 3 standard deviations, that's 3 2.5s, which is 7.5. So all the way on the right would be 72.5. If I did my math right. So to be 3 standard deviations, you'd be 72.5. If you go to the left, the same distance, you'll find that the number way over on the end would be 65 minus, what did I say, 7.5. So that'll be 58, 57.5, I believe. All right, so now we want to know what's the percent between 58 and 80. Well, let's look at 80 real quick. Do you notice where 80 is going to be on this scale? If 3 standard deviations is 72.5, 80 is going to be way, way, way out here. In fact, 80 is 6 standard deviations above average. Well, I think you can probably just make a pretty good guess that there's nobody, hardly ever, that's taller than 86 inches. No woman is typically taller than 86 inches. Or 80 inches, sorry. 80 inches is exactly 6 standard deviations. So that is so far to the right, I'm not sure we're going to have to do much with that. Now on the left side, 58 is technically just inside of the 3rd standard deviation. So for 58, the z-score for 58, we can do that. That's going to be 58 minus the mean, which is 65. Divided by the standard deviation, which is 2.5. That z-score is negative 2.8. That is actually on here, believe it or not. Negative 2.8 tells us that the percentile is, look at that, it's so small, it's like 1/4 of a percent. So there's only 1/4 of a percent, 0.26, it's really, if you want to do it in a decimal, it's 0.0026. So it's like 1/4 of a percent is below 58 inches. So not many women are below that. So how many women are going to be rejected because they're over 80? I would say essentially none. And then how many are going to be rejected because they're less than 58? About 1/4 of a percent. So I think our final answer is actually just this number right here, because since there's really no women above 80, you really only have to look at the left side. So basically, this is saying hardly ever does a woman get turned away based on height only. So that would be the final answer to that one. That one's a little more complicated, but if you draw a picture, I think you can see that it becomes a little bit easier because the one end is so far to the right. All right, so that's it. You have to learn how to find z-scores and how to find percentiles and how to work it backwards. Those are the three main skills. So to practice that, I have a homework assignment. It's also printed on Canvas, but it's listed here as well. 5 problems. A couple of them have some multiple parts, but 5 problems practicing those same exact things. So again, if you ever have a question, feel free to email me. Other than that, have a great day.